Very good afternoon to all of you. We are going to discuss today the seventh topic, comes under the same series, mathematics required for machine learning. Here we are going to discuss about linear transformation. Linear transformation, we have already discussed a little brief overview in the earlier videos, which is a fundamental concept in the linear algebra, and it is used to represent and process the data in machine learning and also for data analysis. I can represent this with a mathematical notation, G maps R suffix n to R suffix m. If g of x is a special kind of function, then it is called linear transformation. That means it is going to transform one form to another form in a linear fashion. G of x is a linear transformation if each term of each component of g of x is a number of times one of the variables. So let me go in detail about these topics. The types of linear transformations are there. There are various types of linear transformations. So one is the data transformation, 2, principal component analysis, 3, image processing, 4, feature engineering, and fifth one is normalization and standardization, data augmentation, seventh change of basis, eighth principal transformation directions, ninth neural networks, 10th data compression. We'll discuss one after the other topics and how it is useful in machine learning. If you look into the data transformation, the linear transformations can be used to change the representation of the data. Suppose we have the data is represented in the 2D form. We can transform by using matrix algebra operations into 3D or into the higher dimensional space. That means if you have a data set with the two features, then we can apply linear transformation to map this data into higher dimensional space to capture more complex patterns. Earlier in one of my videos, I have shown the SVM, support vector missions. There are 2 dimension and 3 dimensions I have represented very clearly. So this is one form of capturing more complex patterns. And the second one, principal component analysis, which is called PCA. So it is a dimensionality reduction technique that involves linear transformations. Higher dimension to lower dimension, because when the data set is with higher dimensions, the time complexity is sometimes it is going to be exponential, by which the system will crash and it will come out. So to overcome those kind of problems and to reduce the time complexity and enhance the performance of the algorithm, we apply principal component analysis, which is called PCA, popularly known as. I can show you here the dimensions means nothing but the attributes. Even here, in both way, we can reduce the number of attributes, we can reduce, number of rows also can be reduced. If you look at how many attributes are here, 1, 2, 3, 4, 5, 6, 7. This can be reduced to, you can see this one, 1, 2, 3, 4, 5 only. It's a just general representation I'm showing. But the principal components are not like this. It is going to be represented in a different form, which is a linear combination of the attributable values or the attributes, we can say. It is a dimensionality reduction. This approach is called dimensionality reduction. Here, higher dimensions and lower dimensions. I mean, number of dimensions are more and number of dimensions are less. the other way around, to find a new set of access principal components along which the data has the highest variance. This is for general purpose I am explaining, not exactly this is going to be like this in principal component analysis. I'm just showing the number of dimensions are going to be reduced. So which features we are going to consider? So along with which axis the data has the highest variance. So that means we are removing the lowest variances data. These new axes are linear combination of original features. That's what I told. The new axes are linear combination of the original features, which are called the principal components, Image processing. So when do we go for image processing? If the image is blurred, if you look at this, part of the image is blurred and part of image is without blur. To remove that, we need to apply various filtering techniques, various transformations, so various image enhancement techniques, so or convolution to images, like that many things we can apply. In computer vision and image processing, linear transformations are often used to apply filters or convolution to images. These filters can enhance certain features to blur the image or perform edge detections. Feature engineering. So linear transformations are used to create new features from the existing ones. That means, example, if you take, create interaction terms by multiplying two features together, which is a linear transformation. If you go further, the fifth type, normalization and standardization. This also I have discussed in the previous video. Normalize the data. There are various types of normalization techniques are there. So min-max normalization, like that we can go for Z normalization, like that many techniques are there. So it can be used to normalize or standardize the data, making it to have zero mean and unit variance. Helps the algorithms converge faster and perform better because of different attributes have different ranges. So it is difficult and it takes longer times. Data augmentation. If it is a technique to reduce overfitting when training the ML model. By training models on several slightly modified copies of the existing data, particularly we use in deep learning and computer vision. Linear transformations like rotation, scaling, and translation are applied to images for data augmentation. So which are rotation, scaling, and translations are three different geometrical operations. Coordinate geometry, you can get it. So increases the diversity of the training data and improves model generalization. These are all possible with matrix algebra. Change of basis. Linear transformations can change the basis of the data representation and commonly seen in coordinate transformations, such as converting from Cartesian coordinates to polar coordinates or the vice versa. So certain times when we are not able to solve the integration part by Cartesian coordinates, we will prefer polar coordinates, and otherwise the vice versa also we can consider certain times. Principal transformation directions. In data analysis, especially in the context of eigenvalues and eigenvectors, linear transformations can reveal principal directions or components in the data. So these eigenvalues and eigenvectors, where do we use? In finding the principal components. That's what it was mentioned in the last line. principal directions or components in the data. So there it is very much useful. Finding the eigenvalues and eigenvectors, again it is a matrix algebra. So this is one of the application you can see. Neural networks. In deep learning and neural network layers perform various linear transformations of input data, followed by nonlinear activation functions like ReLU function. These transformations are fundamental to the functions of neural networks. So the neural networks and deep learning, internally, the linear transformations are applicable. We go to the last topic, data compression. So data compression, earlier I showed in the number of attributes reduced and number of data points reduced. That also you can consider under data compression. This goes with the singular value decomposition. So keeping only the most important components, one can represent the data more compactly. So not important components we can remove, so that this is a data compression technique. Even the components were reduced. Data is compressed. Still we are getting that the hidden patterns as it is. In summary, I can say linear transformations provide a powerful tool for data manipulation and analysis. Allow you to change the representation of data, extract meaningful information, and process the data efficiently, making them a fundamental concept in the field of machine learning and data science. So, in the further videos, coming videos, we can go in depth of each and every topic also with examples. And I'm looking at even for implementations of these techniques using Python and other codes also in the future videos. So thank you one and all. Do subscribe and share and make others also to subscribe, because you are going to get the notifications of the new videos once you subscribe. Thank you one and all.